Okay, so welcome back. And our next speaker is Maria Chiara Parisi, right? Okay. Thank you very much, Maria Chiara. I'm going to make a brief introduction. Maria Chiara is currently a PhD student at the University of Amsterdam within the Institute for Logic, Language and Computation and the Department of Philosophy. She's a member of the Concepts in Motion research group led by Professor Ariana Betty, and her work lies at the intersection of philosophy, data science, and digital humanities. She specializes in the data-driven history of ideas, focusing particularly on ancient philosophy, metaphysics, and the philosophy of science. And the title of her talk is Aristotle and Proclus on Mathematics as an Axiomatic Science, a Data-Driven Comparison. So thank you very much, Maria Chiara, and the floor is yours.
Perfect. Thank you very much for the introduction. I'll try and share my screen. Okay, you should now be able to see my screen. Is that correct? I don't really see you, but
yes, I think
I trust that you see
yeah.
the presentation. Okay, fantastic. Thanks a lot. Thanks. Okay, so yeah, thank you very much again for the lovely introduction and also for organizing this very, very interesting 2 days of workshop. Now we're going to do a big jump back in history, and I'm going to be talking about basically what will be the second chapter of my thesis, which I will defend in a few months. And specifically, I'm going to talk about Aristotle and 5th century Neoplatonist Proclus about their view on mathematics as an axiomatic science. And because this is a workshop on methodology, without further ado, I would like to introduce and talk about the methodology that I've been using for this research, which is also the methodology that we use in our research group in Amsterdam. We call this data-driven history of ideas. And this will also give me a way to introduce basically the plan for this talk. So usually you start with a research question. Now, research questions in these fields are typically very large-scale historiographical question, for example, that goes through centuries and multiple authors, but they tend to trace a concept or an idea through time. And because you're working with a concept, what you really want to be doing is to work with what we call a conceptual model. Why is it so? I mean, we are philosophers and concepts can be interpreted in a multitude of ways, even if we are working with one single concept. So basically what we really need to do is to keep, in order to keep the focus the same or the interpretation of a specific concept the same and to trace that across centuries, we need to make that very, very explicit. And we do this by giving a very fine-grained definition of the concepts under investigation. Then what you want to do is probably to investigate how this concept is behaving or evolving across a corpus. So we work with collection of text in which we gather evidence for our research question. Now, probably what characterizes our group the most is that then we work with concept term clusters. So as philosophers, we work with concepts, and concepts are abstract, but they occur in text, and authors talk about them with terms. Now, the relation between a concept and a term can vary in authors, but in order to keep the focus the same, we always want to make the relation between the concept and the term very explicit. And so we want to map them onto each other. This allows us basically to let's say, map the semantic field of a certain concept so that we can research and trace it into corpora. And we start doing this usually by making an experted guess on the connection between the term and the concepts, and then we check that computationally with the software run on the corpus, and then we expand this list to see actually what are the terms occurring in the corpus, if there are more than we expected, if we want to use them to retrieve more interesting passages. And then we retrieve these passages always, again, with this software. What we do now then is to translate our initial research question into term-based research question, which basically is a way of rephrasing the question from being about concept to being about the same concept, but linked to the term in the text. And then we go on with our annotations. Annotations are both qualitative, so the very traditional, old school philosophical exegesis and close reading. And then we also annotate the passages quantitatively, so that then at the end, we also have a quantitative overview together with a qualitative one. So let me dive into into the topic of this paper. We start as always with a bit of context and a problem. So problem here is that the 5th century Neoplatonic philosopher Proclus, who wrote a very, very famous commentary on Euclid's Element of Geometry, in that work, he attributes very oddly to Aristotle the view that mathematics is not explanatory. Now, this is odd for a series of reasons. First of all, Proclus himself do not endorse this reason, this view. He thinks that mathematics is explanatory, but most oddly is that there is no evidence for this view in Aristotle's writings, and instead there is quite a lot of evidence for Aristotle saying that mathematics is indeed a paradigmatic explanatory science. So scholars faced this dilemma and came up with some solutions. Some of them suggest that maybe there was a conceptual shift in the concept of scientific explanation. So in other terms, basically, they say that by scientific explanation, Proclus and Aristotle mean completely two different things. And they try and explain this by pointing at Stoic influence on Proclus, so that basically there was a restriction on scientific explanation to real ontic causes. So this comes with the consequence that only explanation about real object can be scientific. And this is a bit problematic for mathematics, especially if you interpret mathematical objects to be abstract conceptual objects, then you have that mathematical explanation are not scientific. I don't think specifically this is the way to go, especially because it comes with three big risks. First of all, a risk about accuracy, because it seems that it overlooks a bit, this view overlooks the Aristotle account of scientific explanation. There is the risk of underestimating the continuity instead between these two authors, and really how much Proclus instead inherits Aristotle's frameworks. And then there is also another risk, which is about adaptability of the adaptability of the Aristotelian framework, which is actually how very nicely Proclus tweaks and changes a bit Aristotle's framework and adapts it to his Neoplatonic philosophy. So here the research question is, does Proclus conceive mathematics as an explanatory axiomatic science in Aristotle's sense, and in this way there is no real departure, or does his account fundamentally differ? So my thesis is that Proclus not only adopts Aristotle's axiomatic idea of science for mathematics, but also adapts it within his Neoplatonic framework. So, as I said before, we work with conceptual model, and so I had to make explicit what Aristotle meant by an axiomatic science. This model comes with three parts, which we will see then will correspond to my three sub-questions. So for Aristotle, a science is axiomatic if, first, it needs to have axioms. So immediate explanatory proposition from which all the rest, theorems and non-fundamental proposition follow. Two, it has to explain with via demonstrations. So demonstration are three-part arguments in which the two premises give the reason why of the conclusion. And they have very specific characteristics. So, for example, they need to exhibit a certain kind of predication, per se predication or necessary predication between the terms. And also the middle term in the premises must be or point at one of the four causes or idea. And last, a science is axiomatic if it has a unified subject genus, and this could be a set of objects or terms referring to objects that share necessary attributes, and because of this, they can be demonstrated, they're demonstrable from the same principles. Now, for Aristotle, mathematics satisfy all these conditions, is structured with axioms and theorem, it proves via demonstration, and it studies sensible objects qua quantities. So it actually studies the same object of physics, but under a specific aspect. So qua quantities or in a qualified way. Now, we have three sub-questions corresponding to each of these parts of the model. So we will have the first question is, does Proclus also interpret axioms as presented in the same way that Aristotle did? So as fundamental proposition that explain non-fundamental proposition. Question two, does he also use demonstration in the same way? So are explanation in mathematics conceived as a demonstration with the same characteristics that we just saw? And third, is mathematics presented as a unified science with its own subject genus? Now, to tackle these three questions, I have decided to work on what I call the axiomatic mathematics corpus. Is quite a big corpus of over 3 million word token, and it includes 102 files that roughly corresponds to the whole work or complete corpus or extant complete corpus of Aristotle, Proclus, Euclid, although that didn't come up a lot in the textual evidence. And also I wanted to include two key Stoic authors as well. I built this corpus from the Thesaurus Linguae Graecae XML files, so it's machine readable and we could search it with computational tools. Specifically, we use the, as we will see later, a software called HitBarank. And thanks to Martin Reinhardt, we had to process this corpus through all sorts of operation, which are called localization, lemmatization, and post-tagging. We can discuss all about this in the Q&A, but briefly, this ensured that all the files were consistent and were compatible for the use of our software. Now, a whole lot of a set of challenges also came with it. We can discuss also this later if you like, but mainly working with computational tool on an ancient Greek language can be quite challenging, but this didn't stop us. And now on to what is probably, as I said before, the most unique way of dealing with the relation between concept and terms of our group. So here what we did, as you can maybe see already from the columns, is to map concepts that we discussed already in the research question, and that we have already defined according to a very explicit interpretation of Aristotle, to the terms that actually occurred in the primary text. So we have an initial list of basically functional synonyms that say for that concept, or predicates that immediately identify that concept. So here, for example, in the let's say cluster of demonstration, we have, for example, reason why, cause, explanation, and so on and so forth. And we also give a ranking or a weight to each term, so that we can make explicit also the strength of the relation between a certain term and the concept. And this will help our software then to retrieve first, or give precedence to those terms that are more highly ranked. Um, After we do, so we start with that initial list that I showed you, and then this is how it ranks very briefly works. We have this, let's say, they're called wildcards, and they are usually the first part of a lemma. Be happy to ask me all about this in the Q&A again. And we feed id_parenk this initial list. id_parenk check it against the whole word tokens that are in the corpus, and give us back all the 1 to 4 grams matching that the first initial list. So we end up having quite an extensive expanded list with more term that we started with, and then we curate that list. So that's what you see here at the end. With the expanded curated list, we feed that as an input again to id_parenk, and id_parenk retrieves all the passages with a co-occurrence of high-weighted terms. And this is what we get. I know it's full of information, but do not despair. We are not going to go into all the numbers and so on. But basically, here we have the paragraphs, and here we have, for example, the reference to the paragraphs, or the hits. That these are basically the terms that we searched for. Now, as I mentioned before, because now we are working just with concept, but with concept linked to terms in text, now we are reframing the initial research question into term-based research question, and ask for each of the passage retrieved, does the passage describe axioms or mathematics as proceeding from fundamental propositions that explain non-fundamental proposition? Now here we have the exact term referring to that concept, so the relation is very tight. Same for the second research question. So that will ask, does the passage describe explanation in mathematics? And then you would have something like mathematicos, arithmeticos, and so on, as demonstration, where the premises give the reason why, and you would expect to find a term like dioti, and so on. Third, same about the subject genus. Does mathematics has its own subject genus, and so on. Now, with this, trying to answer this for each paragraph that has been retrieved, I answered this term-based research question, and I score them on a 5-point scale. We can discuss also this more later, but really important 2 points I want to make here is that importantly, annotation are not simply term counts. It cannot be just reduced to that. And this is also why our methodology and our approach is different from your topic modeling or just words in a bag term counting. Here, close reading is still very, very, very essential. And this is because just the occurrence of term does not by themselves detect meaning. So here you would have an idea to what an annotation spreadsheet look like. Still a bit intimidating, but maybe a bit less than the one before. And here you would have the three term-based research question, the scores, some notes for it, some tags for like helping organize all the information. You have the name of the works, the canonical reference. Here again, you can see the collected hits that are the terms connected to the concept according to the interpretation of Aristotle, and so on. So let's see some quantitative overview of the results. In total, I annotated 173 passages. I could have done more, but I also had to deal with time and my human finitude. So this is what I did, but it is scalable for more. I checked on all these passages come from 32 works. I have annotated works from mainly three authors, and the results are that I have 79 positive passages, which are passages that are scored at least 0.5, so that would be a maybe yes to a yes. And I have 94 silent, and this would be at least a positive answer for at least one research question. And then instead I have 94 silent passages that are completely silent for all the research questions. This means that they do not reply directly, specifically and explicitly to the research questions, but they still many times provide very relevant concepts. So it's not all in vain. The big trend that we see is that passages replying to the question positively to a question about subject, genus, and demonstration occur more frequently than the one about axioms. This does not really come as a surprise because although axioms are critical in Aristotle's philosophy of science, he is nonetheless not too explicit in their description, while Proclus instead give us a much more fine-grained description of axioms. So let's see how this played in each of the research questions. First, do axioms explain theorems for these authors? 46 passage replied positively. So for Aristotle, we have that in each science, you have a genus, some axioms, and per se attributes. Passages says also that it's knowledge from principles and that axioms explain theories via demonstration. Now, Proclus adopts all the above, but also adds additional explanatory method of explanation. So he also had analysis and the synthesis and also dialectics because he's a Platonist, Neoplatonist. What he does is to extend this very same order of explanation. He doesn't use it just for his philosophy of science, but it's embedded within his own ontology and natural philosophy. And then, as I just mentioned, he really, really clarifies all the distinction between axioms and postulates and theorems versus problems and so on. So what we see here is that Aristotle's axiomatic ideal is flexible, and Proclus expanded, adding on top, but without changing or departing from his fundamental explanatory structure. For question number 2, are demonstration causal or explanatory in the same way for both authors? 67 passages reply positively. For Aristotle, we just saw that the demonstration are syllogisms or three-part arguments from principles. They need to have an explanatory middle term with certain characteristics. And he's very explicit about the fact that mathematics really exhibit paradigmatically this type of explanation. Why? Because they use a lot of first figure syllogism, and the first figure syllogism, his words, are the most scientific of all. Now, Proclus preserved all of this. He also proved from accepted proposition. And what he adds is that the middle term needs to be in a per se predication with the other term in the premises, and it has to be in the same genus and also in the same ontological layer. So it's not just the object of the science that has to be from the same genus, it's also the object in reality that the object in the science are referring to that must be from the same genus. And then he applies this demonstrative form really beyond mathematics, a bit everywhere, but maybe most interestingly in his cosmology and in his commentary on Plato's Timaeus, to explain how the creation of the cosmos. So here we have that mathematics is explanatory for both, and Proclus adapts but does not reject Aristotle's causal necessity of demonstration. He just adds that and adapts it into his Neoplatonic ontology. And finally, and possibly the most interesting, is the question about the subject genus. So here we have 67 positive answer. We have that for Aristotle, mathematics is a general science that studies object qua quantities. Now it's general because it has many disciplines that it subsumes, and it studies sensible object, as we say, but as we said, but qua quantities. Now, these objects are not real ontological objects in reality. So the unity of the subject genus here is achieved through three logical operations, with the qua operator, the abstraction, and the separation, but it does not require an extra ontology. In other words, for Aristotle, mathematical objects do not need a ontological counterpart to be out there. Yet, mathematics is a valid science, and he positions it between physics and metaphysics. So it has an intermediary role. Now, Proclus keeps the above, especially the point 1 and 2, and he 1 and 3, and he also interprets mathematics as a general science. But for him, general science is a general science of intermediate objects. Now, he requires instead an extra ontological layer of what he called metaxou, so intermediate object between the intelligibles and the sensible. This is really the key distinction in all of this paper that occurs between the two. But as you can see, this is not really a distinction that pertains to the philosophy of science or a distinction that concerns the structure of the explanation. If anything, it concerns ontology. Also, as Aristotle, he describes mathematics in an intermediary position. Mathematics receive principles from above, from metaphysics, and distribute principles to lower sciences. Reframes it within new. Most likely, this speaks to the portability of Aristotle's ideal of axiomatic science that can accommodate very almost, let's say, even opposite ontology of mathematical objects. And so to conclude, we have seen that there is quite a lot of continuity between these two authors. They both treat mathematics as a paradigmatic axiomatic science, from going from axiom to theorems, explaining through demonstration, and also having a unified genus. On the if whether to interpret that genus as just object of science or ontological object, that's up for an ontological discussion. There is also a very nice adaptation from Proclus of this axiomatic ideal. So it extends beyond mathematics, goes into natural philosophy. He adds more method to it, and his characteristic is that he maps then mathematical object to ontological entities. There are some limitation, of course, of this paper, and one is that although I wanted to include some Stoics, the text from the Stoics did not really come up as much, and this is because it Parank, as almost all computational tools, favor the retrieval of longer text. The longer the text, the more the key words occurring in it, the more he ranks up. Also, another problem was that that this also often happens with computational approaches, is that all the canonical reference disappeared, and so basically we had to add it manually again. But there is also hope for further work, and one example could be tuning this software HitParang for fragments and train it on fragments, and so that it will eventually work. Another way could be to just simply broaden the corpus, and you could supplement it with more authors, more centuries, more languages, and so on. Also increasing the number of annotation, so that will make the data set even bigger. And finally, also tracing it would be nice at this point to trace the shift in the ontology of mathematical objects, so that we could really trace this distinction between object of science or objects studied in a qualified way versus mathematical object as corresponding to ontological objects. Thank you very much.
Oh, thank you very much, Maria Chiara, for this wonderful talk. And now we can open the discussion. You can raise your hand. Kirsten?
Hi. Thanks. That was really cool and really fascinating. It definitely cleared up a few things for me about the relationship between kind of axioms, demonstrations, and subject genus in those in Aristotle. So that was really helpful. I have two questions that are kind of related. The first one is about kind of what it is that your algorithm is able to, or what your program is able to pick up. And I was kind of curious about whether it's kind of just terms or whether it is able to scour for kind of presentation, like style things on a page. You know, like, is it able to pick up the use of syllogisms by kind of noting that the way that these things are kind of sitting on the page in sort of 3 lines and things like that? So that was kind of one question. And the other one is kind of, I guess maybe it's a bit mean in a way. I'm curious about what these digital methods actually bring to the scholarship. Is it just a matter of scale? Is it just that, you know, you're able to comb through so many more resources and so on, and then really just kind of, it really allows you to hone in on the ones that are really important, and allows you to kind of do things like counting key terms and things like that, you know, we could all do manually, but would take a really long time and so on, and maybe we would be more, we'd introduce more error? Or is there something qualitatively different that you're kind of getting when you're doing this kind of work?
Okay, thank you very much for both questions. So, to the first question, no, the software does not do that kind of picking up argumentation, but I know lots of people that are working on that type of software. One of them is, especially for ancient philosophy, is Daniele Morrone. He's doing a amazing postdoc in Leuven. Our is actually, HitFrank is basically a very sophisticated term search. But what a term search, just simply like a Control F, cannot really do is to search all at the same time these big clusters of words and terms, all at the same time, and also taking into account the strength of relationship between the terms and the concepts. And that's really, I think, something that, probably linguists are not really interested in that, but we philosophers really, really are. So that also something that is definitely added with this software. And it also works not just with the exact terms, but it works with lemmas. So lemmas are basically the dictionary form of the word. So you would have a multitude of terms that are related, of word form that are related to this root of the lemma. And this, of course, might not be sound not super relevant for English, but when you work with ancient Greek and Latin and you have 21 different word forms for the verb to go, you really want to work with lemmatization. So this is basically what HitFranks does. So the output of HitFranks are, first of all, this list of basically all the terms that are in the corpus that match your initial list. So these are quite big list. And from there, you can curate this list for the things that you are interested, many you're not interested into, but sometimes nice things come up that possibly you haven't thought of before. And finally, then you feed again this expanded curated list to search the passages, and then the HitFrank gives you back these passages, and it also prioritizes them in taking into account not only all the lists but also the weights between the terms and the concepts. On the matter of scalability, yes, okay. First of all, of course, it enlarges and it expands and it makes it, it does things that humanly are not possible. But at the same time, what it does is that it makes I think, so it's not just, okay, use the computational tools, you'll have a better result. What I really believe in is the whole package of qualitative, quantitative, and computational together. So what we're really pressing on is keep the human inside the loop, keep the human asking the question, and then use the machine to, like, as a support for that. That's also why I stressed that the annotation of the passages are not simply term counts. We need the close reading all the time, because simply term occurrences doesn't really give meaning. Not especially for us philosophers, like that could mean so many different things. Just a term that occur, doesn't say much. Another thing that I like about these computational methods, or better, the whole data-driven approach, is that it gives a way to the researcher to be very, very explicit. And so the research is, I mean, I do not really believe in objectivity. Oh, sorry, this is a strong statement, but like objectivity or truth, but at least we can be explicit and make our bias or our interpretation very explicit, so that then we can communicate and talk about this interpretation very explicitly. And so like a computational tools, or better, this whole methodology, I would say, because it has all these steps and is quite controlled and repeatable, I think it's a great step for a history of ideas and history of philosophy to go towards that direction. Nothing to take, I mean, there are people that would just like work with fragments, and it's perfectly fine, and you don't need this kind of methodology for it. But if you want to make big historical, large historical claims, and we usually kind of tend to want to do that, then this is a way to do it in a supported way, I think, more explicit. Yeah.
Yeah, thanks. That's really helpful. I mean, I think you're right that that yeah, for especially for these kind of big historical claims, I think that you're right that these are just really good methods to be using that are going to help you to avoid kind of biases and stop kind of missing things and so on. Yeah, really great.
Yeah. Yeah, and really, if I may just add a point, really, in one of the other paper on my thesis, there is there are some authors that if you take an even bigger corpus, just let's see whatever it's in there. For me, especially, there are, for example, commentators on Aristotle that are traditionally considered like a class B, C, D, and so on. And then instead, they are the source of some marvelous mix of school of thoughts, and you can see all the terms, how they've been used and traced through the centuries. It's really great for this kind of research.
Yeah, thank you. More questions? I have a question. Maybe it's a naive question because you are using, the theology corpus, but what happens, for example, if you have a new edition of the metaphysics text, like the one I understand Prima Vessi is working on, so it might change just a little bit your I don't know, your terms, right?
Yeah.
But maybe it's just a little bit, so it doesn't change your whole picture, or what happens if we change?
So yeah, every time that we use we pick a corpus, at least in all our paper, we are very, very explicit on all the metadata that has been used, and sometimes it's the a TLG. Some other times I've used also bigger corpora, for example, Open Greek and Latin project, which includes like a plethora of the text, and it's not just philosophy, because I wanted to just see whatever was there. But every time, all these papers all these papers come with an enormous bag of metadata and documentation and all of this, just to make sure that then basically, ideally, one could go back to the XML file and look.
Okay. And then if in the future you have a new corpus, you can just add it to your search.
Yeah, you supplement it. Yes, you supplement it, and you can give update. It's a bit I don't know if you're familiar with people working with software use GitHub, and they publish update. So when you refer to a corpus, you usually refer to a corpus in a specific version. So I don't know, TLG version 1.2. Yeah.
Okay, thank you. And I
Thanks.
think we had another question, but now
Oh,
I don't see.
Hello, can you hear me? Or-
Yeah, we can hear you.
Great. Hey Maria, long time no see.
hi. Yeah, I
Uh,
recognize the office.
yeah, no, from Amsterdam indeed. Really great talk. I'm very excited about your
Thanks.
research and looking forward to your defense. I was just wondering about the because you were emphasizing it, the distinction between the concept and the word or the terms. And I know in German Begriffsgeschichte, there's always been this issue of like, what is the Grundbegriffe and how does a Grundbegriffe differ from just random concepts, and you seem to polarize these things, but do I need to understand the differentiation between the conceptual map and the terms in there as mapping onto the differentiation in linguistics, as in between like what was it again, like semiology and onomasiology. So on the one hand meaning, on the other hand the lexical item. Does it map onto that? And if so, isn't it epistemically at least more safe, you could say, to stick to the surface level lexical item? So so simply the terms rather than the concepts, because in my experience, having done some of this kind of research, I found a huge benefit in sticking to the term, because at least you could claim that there is a kind of lexical continuity, like an empirically philological continuity across texts. Whereas if you include, if you look at meaning, it becomes ambiguous. You need interpretation, you need annotation, you need to, and also on top of that, it becomes very abundant. Like these conceptual domains, these semantic fields, they can like they grow and grow, and then it's simply like very nice to stick to the surface level of lexical items or just terms. So how's your how do you rate that?
Yeah, so maybe maybe I have a counter question. I have some point. Let's see. Okay, let's see how can we do this. So yes, it can be abundant, but at the same time, we work with definition and making this relation explicit, specifically because you don't want to include an infinitude of relation between terms and concepts. Okay, and this is one thing. Another thing that you say is, wouldn't it be nice just to stick to the terms? Yes, but if you are interested in tracing the use of the term, if you're interested in tracing the idea and the concept, that wouldn't really work, does it? Because you said like sticking to the term, then doesn't that, what I mean is that doesn't that, for a philosopher, usually, doesn't that always come with that layer of interpretation, so that you implicitly then you would either connect it to a concept implicitly and then keep on saying, no, but it's just on the term level, or then it's just a linguistic interest. And then you're not mapping the concept, but mapping just the lexical term in the text.
Yeah, so the only maybe understood as a counter question, I would say that when you cross the line from the lexical item to the meaning, and you try to determine and fix the meaning and the whole domain, there is just this interpretation going on. And then this interpretation is projected back into the past, and all kind of words may flower into that, even though you have rules for ascribing. The nice thing about the lexical item is that, of course, you lose a lot of meaning, but at least you can, for instance, start working from where it receives the meaning like the dictionary meaning, for instance, that you are like most interested in, and then at least you have a clear starting point of where to analyze, even though the word might be older, but have a very different meaning, and you can identify that through like historical dictionaries or something. I mean, of course, you might lose older discussions or meanings in your, but at least there is some like, yeah, I don't know. Does it make sense?
I would, yeah, it does. It does. I would go far and say, even if you take a description from a dictionary, somebody has done an interpretation there. So you are always already working with some sort of concept connection. And since it is this, I say at this point, why not make that super explicit?
Yeah, fair
Yeah,
enough, fair
yeah,
enough.
but completely understandable point. Yeah, that's also
Yeah,
why it's very
because
important to keep. Yeah,
but because what happened in the if there are no other like questions, I don't want you. If there's other questions, then please go ahead. But like this is why in the French, like the Begriffsgeschichte of French terms, that is still like ongoing, being published by Reichenhard, a student of Koselleck. Because they started to focus more and more on meaning rather than the term, the lemmas became bigger and bigger, and suddenly all kind of different terms were leaped together, like constitution and citoyen and that all, and it became actually a big mess. And this is and so there you could see like how sticking to the lexicality has a benefit of not getting lost in these like but then again there is no but
I would love to learn more about it actually, like what's the reverse how it could go. Thanks for this.
And you thanks a lot. It's very interesting.